Hello, everyone. My name is Liyuan Xu. I'm a PhD student from the Staiger lab at the Purdue University. Today, I'm going to talk about my project, which is the inhibition of actin filament nucleators enhances de novo filament nucleation in Arabidopsis. So first, let's go through the nucleation model very quickly for the actin filaments. So there were two major actin filament nucleators, Arabidopsis and Formin. Arabidopsis can mediate the branched filament nucleation, which is just creating new filaments from the side of a pre-existing filaments. And the Formin can create actin filaments from de novo, and also some isoforms can form the actin filaments from the side of the pre-existing filaments. And what we find is losing functional aptitude with like genetic mutations can lead to different kinds of epidermal cell morphology in Arabidopsis, such as the adhesion defects between cell ends and also distorted trichome. And also, ARP23 mutations can cause much shorter hypocaudal growth. And when we look at the actin structures within the cells, when we compare the ARP23 mutants with the wild type sibling, we can see like the filament abundance is much reduced, and those filaments are much thinner. And this is confirmed by statistical analysis, quantification analysis. So you can see the density is much reduced, and also the filament bundling is also much reduced. And another thing we find is like when we apply this ARP23 inhibitor 66666, which is commonly used in yeast and mammalian cells, we find similar effects on actin structures with the ARP23 mutant. And when we look at the filament nucleation frequency, you can see when we separated them by their origins, the nucleation frequency was it decreased a lot, and only the side branching filaments side branching nucleation events was decreased with either the genetic mutations or the 6666 applications. And another thing we did is combined this ARP23 genetic mutation with the forming inhibitor, the small molecule inhibitor of forming homology 2. And surprisingly, what we find is when we apply this forming inhibitor on the ARP23 mutant, the filament abundance was increased. Here you can see, but the filaments are much fragmented. It's like a smaller and it's non-branched. Here you can see the quantification analysis. The actin density is even higher than the wild type, but the skewness or the bundling of the filaments are reduced. And when we look at the nucleation frequency, the total nucleation frequency of the mutant ARP23 mutant with forming inhibitor is increased a lot, and this increase is only coming from the de novo nucleation events. So to conclude, we find ARP23 is involved in the regulating plant growth and axial cell expansion, and also it's confirmed like in vivo, this ARP23 is nucleating side-branched actin filaments, which is the first time in living cells. And we also confirmed this small molecule inhibitor 6666 can be used in plants as well as a ARP23 inhibitor. And also we find this surprising increase when we genetic and chemically depress the ARP23 and formin. It caused an increase in filament abundance by an unknown mechanisms. So thank you for listening. And if you're interested in this topic, I'm I'm presenting the poster number 59, and welcome you to come talk with me about like how could this be possible with this enhanced de novo filament nucleation when we knock out all those nucleators, known nucleators. Okay. Thank you for your attention.